Unit 17, Part 7. So 5 and 6, right, which were similar, as we saw, the existential, binding the lover, universal, quantifier bound the lovee position. Despite that similarity, they have very different meanings. Another way of making clear how they have different meanings, they have different truth conditions, right? How is 5 true? There exists some one x, such that what is true about this one x? Well, for every single y, x, this x that I'm talking about, loves that y, right? We call this the Jesus sentence. There is one person that loves all of them. For this to be true, it has to be true of one individual, that one individual is loving every single one, right? Despite the similarity between these, 5 and 6, this to be true does not require that same condition, the one loving them all, right? For every single y, what is true about each and every one, for every single one, there exists an x such that x loves that y. Okay, so everyone has a lover, so everybody gets loved in this one, but everyone gets loved in this one. This is only true if everybody gets loved by the one person. This one is true if everyone gets loved, but it can be by a different person in each case, person by person, in each case, in each person. You can have a different lover, okay? Another way that Klenk makes clear that swapping the quantifiers around, right, changes the meaning of the sentence, changes what kind of subject it is, it changes what kind of sentence it is, that is, it changes the form of the sentence. Right? This is a universal statement, asserts something true of it being true of everything. This is an existential statement, tells you something is true of a particular individual, or at least one. It's true of at least one individual. If we have fxy as x is the father of y, look how this, which again has the same similarities that 5 and 6 had, and that 3 and 4 had, this similarity as well. Universal binds the second position, existential binds the first position in both cases. But if fxy is x is the father of y, look how here we get one sentence true and the other one false, right? This says, for every single y, there does exist some one x, such that x is the father of y. Right? Everyone has a biological father, okay, which is true, but it's only true when my biological father, I have a biological father and you have a biological father, but my biological father is different than your biological father. At least I hope so, because I was raised thinking I was an only child. So, different father in each case, right? There exists an x, different x in each case. For every single y, right? So this now holds of each one. There is one that is the father of this. There is one that's the father of each one. In the not in the ambiguous sense in which that sounded, but in the sense that there exists for every single y, there is one x that is the father of them. So everybody has a biological father, different one in each case, but this says something else. There exists some one x. This is an existential statement telling you that what follows this is true of some one x. There exists some one x such that for every single y, x is the father of y. Right? This is only true if there is someone that is the biological father of every person, which is false. Okay? So that's just clear that, right, we kept the function with the same order, fxy. We had an existent x, we had a universal y, swapped them around, very different sentences, very different meanings, very different truth conditions. Okay, for page 322 to 323, she goes through, so this has been going from reading symbols back into English. 322 to 3, Klenk goes through how to translate English into symbols, how to symbolize English sentences. So what I'm going to do is just go through some examples from exercise 4, from question 4 in the, read this, page 337, which is the exercises. Question 4, So I'll show you how to do these, and these are important. You'll be doing translations in your exam, check practice exam 4. There's translation questions, and I recommend using the method I'm about to use. So here you've got 2 predicates we need to use. So I'm doing for, F, G, K, and L. K and L are 2 of the harder ones. So we've got R, X, Y is X respects Y, 2-place predicate, and we also have a 3-placed predicate, I, X, Y, Z, X introduced Y to Z. Okay? You have to be very careful in the order, right? And this is how I would do it. So R, X, Y, R, X, Y, X respects Y, I, X, Y, Z, X introduced Y to Z. Right? Note the similarities and differences between these two. We'll get to it. There is someone who respects everyone. So this is how I do it, right? I will put down, so obviously the respects predicate is involved, right? The respects predicate is the 2-place predicate, so I'm going to fill these 2 places, maybe with individual constants, right, if there's people involved, but maybe these are variables that are quantified over, okay? Now, what is the form of this sentence? That's what Klenk says is the first thing you should do. Determine the overall form. This is clearly an existential statement, okay? So the first symbol, right, there is someone, I'm asserting that there exists at least one, for which what I go on to say is true, okay? So it's going to start with an existential quantifier. So let's have it, there exists an X. Now, this is what I do straight away. I figure out where that X goes. Is this one doing the respecting, or is this one the one respected, right? What is this one? There is someone who respects everyone. Emphasis on respects to figure out, what am I saying about this one? This one, he or she respects everyone. So it's the respecter. There is someone, existential X goes there, who respects everyone. Everyone, that's the universe, that's going to need the universal quantifier, so that's going to get for all Y. There exists an X such that for all Y, and of course Y is going to go here. Respects everyone. X respects Y. Read it back, make sure it's equivalent. There exists some X such that. This is true of him or her. For every single Y, X respects Y. Yeah, there's someone who respects everyone. That's what that says. Someone introduced Amy to John. Someone introduced Amy to John. So what's my thinking? What's my logical thinking? Okay. Quantifier, predicate letter, 3-place predicate letter, right? Individual constant, right? That's a name, that's a name. Names, people are represented by names and symbols, you get the individual constant, okay? So the first thing I actually write down is the predicate letter involved when it's just one predicate letter like this. Okay, so it's I, bang, 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 right? And remember I've got to pay attention to the specific form of where everybody is in the 3 places. It's X introduced Y to Z, right? Someone introduced, right? A number of ways you might do this. Let me do it the way perhaps Klenk would like best. Determine the overall form. It's clearly an existential statement. It begins with someone. That's a definitive clue. That, right. Now, let me ask where this X goes. Someone is someone introducing. Is someone the person? Is this someone I'm speaking about the one doing the introducing, or the one introduced, or the one whom is introduced to? Someone introduced. It's X introduced Y to Z, so that X goes here, right? Someone, it's I, X, Y, Z. The predicate is defined as X introduced Y to Z. So where does Amy go? X introduced Amy. And this one, it's sort of the order here happens to match up with the order in which I put them. A for Amy, J for John, right? Make sure you've got the right number of variables and quantifiers. Right? Here we had two variables. Every variable has to be bound to have a sentence. Right? I've got two quantifiers, good, good. Here I've got three places. Only one gets a variable, the other two get individual constants. Only one variable, so only one quantifier. So this says there exists an x such that x introduced Amy to John. Right, that's good. The other way I might have done this is Amy and John, they get letters, so let me ask where they go before I dealt with a someone. Before I put that out, I might have put, what's Amy? Amy's the one introduced to, sorry, Amy is the one being introduced to somebody else. So it's X introduced who? This one. Oh, so I would have put Amy there first of all. That might have been the first thing I put there, before the X, before the J. To John. Okay, so it's X introduced Y to Z. So the one introduced to, that's the third position. I put John here. Okay? All right. Everyone was introduced to Amy by someone. Note these, okay? Compare that with this. Everyone was introduced by Amy to someone or other, which is K and L. Okay, so I'm going to put down my I, because the predicate is clearly X introduced Y to Z, right? You could note that everyone is the first word. Everyone, now what I go on to say is true of each and every one. It's a universal statement, right? For all X, everyone, okay, now this bit requires some thought. Was introduced to Amy. It's X introduced Y to Z, so the X actually goes here. They're the ones being introduced, and it's X in the in the definition of the predicate letter, right? It's always for two-place predicate letter, as Klenk explains, it's always predicate letter X, Y. For three-place, it's always defined X, Y, Z. So in our definition, it's I, X, Y, Z. X introduced Y to Z. So I'm using X for this everyone, but that goes in the second position. Because what am I saying about everyone? That they are introduced. It's this introduced that, and that's where the X goes. So to Amy, and I might have put the Amy down right away, just to fill one of the places properly. It's blank introduced blank to this one. Which one's this one? Well, to Amy, so that's that one. Okay? So that's an A. X was introduced to Amy by someone. This someone existential. So it's going to get the existential Y. But that Y is going here, right? It's for every X, there exists a Y, such that Y introduced X to Amy, which sounded out is equivalent to this. Okay? Finally, everyone was introduced by Amy to someone. Okay, again, I, blank, blank, blank is how I do that. You can see. Okay, it's introduces to Okay, let me start with the everyone. It's, so overall form is it universal again, it's everyone. Now where does that for all X go? Right? Notice that, so let me take stock. Everyone was introduced by Amy to, yeah, that's right. Everyone was introduced by Amy to someone. I've got to have two quantifiers. I've got Amy. Where does Amy go? By Amy, so Amy's here, right? Introduced by Amy to someone. So Amy's going to go here. Amy's doing the Amy's doing the introducing, right? So everyone, for all X, what does that bind? Everyone was introduced. That's here, right? Yes, that's here. And then to someone. The to is the third place. It's introduces to third place. And it's existential, so it's existential Y gets there. For every X, there exists a Y such that Amy introduced X to Y.